this video, we are going to continue the PN junction diode. The electrical charged atoms are called ions since they are no longer neutrals. Okay, the electrically charged atoms are called ions since they are no longer neutrals. In this diagram, we can see the electrons and holes recombination, and we have formed a depletion region where the electrons and holes are combining together. After several collision occurs, the electrical field is great enough to repel rest of the majority carriers away of the junction. After several electrons and holes collision, the electrical field is greater enough. The electrical field is greater enough where we gain high electrical energy, and the rest of the holes and electrons and holes are in the junction. The region is produced immediately surrounding the junction that has no majority carriers. Where there is no majority carriers, a region is formed. The region is called a depletion region. After the various times of electrons and hole recombinations, by giving an external supply, the electrons and hole recombination occurs for several times, and finally we get a minimum number of electrons and holes in a region, in a junction, where the junction is the junction is called depletion region. The junction is known as barrier region or a depletion region, which is between N-type and P-type materials. The physical width of the depletion region depends on the doping level. The physical region of the depletion region depends on the doping level, the impurity atoms we add to the semiconductor devices. PN junction diode. A semiconductor diode is a two-terminal electronic component with a PN junction. This is also called as rectifiers. A semiconductor diode is a two-terminal electronic component. The combination of electrons, p-type electrons and n-type holes, we form a product called PN junction diode, which is also called as a rectifier. The anode, which is the positive terminal of the diode, is represented with A. Okay, and the cathode, which is the negative terminal, which is represented with K. Here is the symbol of diode, where we have K is a positive terminal, that is called as anode, and the K is represented as cathode, which is a negative terminal. The right side we have the diode equipment. Biasing of diode. We have two types of biasing, whereas forward biasing condition and reverse biasing condition. In forward biasing condition, the electron, the supply will be in the positive side, where we have the forward biasing condition, and in the reverse biasing condition, which is biased through the supply voltage will be of negative to positive, so it will have a negative current flow. Negative reverse bias. This is forward biasing condition, and this is reverse biasing condition. Here we have in reverse biasing condition, we'll have a large number of depletion regions. The peak inverse voltage can be defined as, we can gain a peak inverse voltage, which is defined as the maximum reverse voltage that a diode can withstand without being destroyed. The maximum reverse voltage that a diode can withstand without being destroyed is called peak inverse voltage. Peak inverse voltage is called maximum reverse voltage. Reverse voltage is called that where we are giving negative to positive. for forward bias we are going from positive to negative, and in reverse bias condition we are going from negative to positive. So this is called inverse voltage, right? The maximum inverse voltage with a diode that a diode can withstand the maximum reverse voltage without any destroy is called the peak inverse voltage. This is the VI characteristics of a diode, where we have this is the practical diode circuit. We have variable resistor, voltmeter, ammeter, and diode, PN junction diode. We have positive forward bias, positive voltage, and in a reverse bias we have a breakdown voltage also. Thank you.